chapters from this year. But then J Advanced is not that predictive. Out of those 18 questions, which is 36 in total, around, okay, you know, most of the questions are cumulative, interlinked from 2 to 3 chapters. On the basis of that, and if you will see the total number of chapters from chemistry are almost 30. Nearly 30 chapters are there. So if I talk about the probability of a chapter is almost 80% of a question being asked from solutions chapter is 80%. Where in this 80%, I'm considering both the fact that it will be a complete question from solutions or it could be a part. Okay, but solutions will be there. It is an interlinked question. It could be an interlinked one. Now, if you ask me, like someone just asked me that if I talk about the number of questions, like Azan asked me. If you talk about J means, there is one question from here directly. Mostly very rarely we have seen 2 questions from this chapter. Mostly the number of questions coming from this chapter is just 1. Okay, 4 marks. And if I talk about J Advanced, yes, again, I would say it is 0.6 to 1.2. Appears to be an odd number, isn't it? For the number of questions, 0.6 to 1.2. Now, it means it is about the interlinked portion. If there is a combination of 2 chapters or 3 chapters, so we give them segregations, right? So this is the importance of this part. The third question is, what are the important topics? Since you are telling us the analysis, you should be telling us the important topics. You would be having that question. So बच्चा लोग, the important topics from this chapter भाई बहुत सीधे से हैं. First, mostly the questions come from qualitative properties, the hot favorite topic of JEE. Qualitative properties, hot favorite. You already are aware about the 4 qualitative properties: elevation in boiling point, depression in freezing point, relative lowering of vapor pressure, and osmotic pressure. Out of all these qualitative properties, again, JEE has his hot favorite, and that is boiling point. Don't know why, but then it has been observed that they ask a lot of questions from this topic. Elevation and boiling. It is their hot favorite. Now, in this boiling point part, or in this entire qualitative property, they can ask you any type of question. Any type of question means it could be a normal question, okay, or a want of question. So that means using the want of factor I. Now from JEE, my major bet will be on want of factor. Questions relating want of factor. Those are comparatively the hot favorite parts of JEE. Now, second place from where they are mostly going to ask you questions is the Raoult's law. This is the second topic from where they ask you questions. Now, if you talk about JEE, now you have seen Raoult's law is comparatively very easy. So if JEE has to create a question from it, majorly the question is either graph based, because that gives us confusion. We do not know very strongly how to read the graph of Raoult's. That's the major drawback. Or it is based on the ideal and non-ideal solutions. So they can ask you with respect to what is the deviation type, positive, negative, forces of attraction. What about CBSC? So I think you are going to have this revision from CBSC also, na? I think Kajal ma'am is taking mostly. But yeah, if I talk about CBSC, then I'll tell you. CBSC's major focus, because this year the things are objective, right? So CBSC's major focus, Arshia, would be the direct questions of Henry's law. Okay, Henry's law, direct questions, numerical based questions. Second, Raoult's law, concentration terms, and simple questions of qualitative properties. Now, simple question means direct, where you just apply the formula of delta TB is equals to KB into M, and you get your answer. So mostly, all in all, I would say the entire chapter. Okay, now, normally, CBSE is expected to ask theory-based questions more, normally, right? But if you see this year term 1 syllabus, yeah, so you have solid states, solutions, P block, then you have this haloalkanes, haloarenes, biomolecules, and this alcohols, phenols, right? Now, if you'll see, there are only 2 chapters which are numerical based. Yeah, only 2 chapters, solutions and this part, solutions and solid states, right? So what I'm expecting is that there will be a better numerical questions from solutions chapter. Because solid state में the questions which can be framed is density based. या तो question आएगा, या फिर they can ask you about that these many atoms are occupying this tetrahedral on voids based questions. So, बस, ठीक है, but mostly density based questions are सकते हैं. Assertion reasoning and this case study based questions. Okay, they can have a mix and match type of questions where they can ask you 1 or 2 questions out of the 3 questions or 4 questions based on the case study part. So वो questions इस तरीके से हो सकते हैं that they will be asking few on theoretical part and few on this part, numerical portion. Okay, but my major chances are like, again, they could ask more case study based questions in organic. Organic में ज़्यादा strong बनते हैं questions because in this term 1 you have SN1, SN2 and stuff. Remember, thanks to CBSC, you have that in the first grade, first chapter, right? So SN1, SN2, and then those optical isomerism based questions. So yeah, we can expect that part from there. Okay, are we clear up till here? The things that we have discussed, the analysis. Yep. All right. So now let's go towards a quick recap of this chapter. And after the recap, of course, I'll give you time to ask me as many questions as you want. Okay. So first, I'll give you a quick recap. See, if you talk about this pyara sa chapter, the solutions chapter, as per your NCERT, now a very good part about this chapter is, even if you are done with your NCERT nicely, okay, and I'm betting on this, even if you have done your NCERT nicely means with proper understanding, I can guarantee you, you can easily treat a JEE mains level question. Very easily. Like JEE mains is not a big thing. Advanced could be a little tricky, but only could be, I would say. I won't say it will always be tricky. Okay, so this is one of those chapters where NCERT will help you to get into the right place. Okay, so this is a chapter with less efforts and more marks, right? Now, if you talk about the concentration of solutions, now, if you talk about, first I'll talk about your NCERT. So NCERT deals with this solutions chapter, okay, as a binary solution. So in this grade, we are just dealing with binary solutions, which means these are the solutions composed of two components, right? One of them being lesser in amount, the other one being higher in amount. So lesser one is known as solute, the higher one is known as solvent. Agreed? Now, you are already aware, and this is something which you've done in 9th grade, that these solutions actually means true solutions, which is a part of a mixture, right? That is impure substances, but is homogeneous in nature. This is homogeneous in nature, right? Now, if you talk about your NCERT first talks about the different ways and manners by virtue of which you give the concentration of the solutions, right? What are the different ways by which we provide the concentration of the solutions? Now, for example, if I talk about these concentrations, so there are many different concentrations, notable being mole fraction, molarity, molality, normality. So mole fraction, as the name suggests, it's the fraction of the moles. Moles of one component divided by total moles, where this mole fraction is represented by xi, which is nothing but a fancy X. Xi. Okay. Now, since it is a solution, it's a binary solution made up of two components. So if you talk about mole fraction of first component plus mole fraction of second component, that will always be equal to 1. Right. The next concentration term is molarity. Right. So Abhin Raj has given me the answer as 1 and then 1.00. Now, this is a wonderful thing that you've done, Abhin. So, because you see, there are these numerical based questions in JEE, right? Particularly if I talk about advanced. So, the integer based questions, they want the answers as 1, 2, 3, 4, 5. And then there are these numerical based questions which ask you for the answer as 5.35 up to 2 decimal places. And if by any chance you forget to do so, and in spite of the fact that your answer is correct, suppose the answer was 1, but you had to give the answer as 1.00, you just gave it as 1, they will deduct your marks. They will consider it as a wrong answer. And on that basis, JEE is harsh. Right? It is cruel. So yeah, whenever you write the JEE examination, instructions are the key point. Instructions are very, very important. Yeah. Enjoy mock you wrote. See, I know this is a fact. It happens. You have to just see the answer like the way they want the answers. Okay. So instructions are very important, and we are in the habit, okay, कि ऊपर लिखा तो होगा, that whether it's a numerical type or more than one correct or single correct, don't go that. Read the instructions carefully. Now, molarity, as you're aware, it is number of moles of solute per liter of solution, devoted by capital M, right? And this is something which is dependent on temperature. It's a temperature dependent quantity. Yep. Now we talk about molarity, small m, that is moles of solute per kg of solvent. Now here solvent is very important. Okay, this is per kg of solvent. Now this is one concentration term which is independent on temperature, which is not dependent on temperature. So can you tell me the reason why? Why is molarity dependent but molality isn't? Right. The major reason being that volume is dependent on temperature. So if there is no volume term, then luckily there will be no dependence on temperature. Right? Right. Mass is independent of temperature, so it doesn't matter. Great. Right. Now, if I talk about normality. Now, normality means the number of equivalents present per liter of solution. That's normality. So my question is, what are number of equivalents? N into moles, right? Just dependent on the N factor. These are number of equivalents per unit volume of solution in liters. Correct. So these number of equivalents are given as the mass upon equivalent mass. And this equivalent mass is given as molecular mass by N factor. And these number of equivalents, as you guys rightly said, is actually dependent on moles as N into moles, where N is nothing else but N factor. Now, how do you calculate this N factor? How do we calculate this N factor? Depends on acidity and basicity. Very right. Very true. Very true. Individual ion then charge directly. Very true. Very true. Salts, the charge of the anion or cation, right? The number of H plus, replaceable H plus, OH negative, right? So this N factor is dependent on the category or the nature of solute that I'm discussing, or the nature of substance that I'm discussing. For example, acids, it is the number of replaceable H plus ions. For bases, it is the number of replaceable hydroxide ions. For salts, it is the cationic or anionic charge. Yes, right, Aaron. We can do that. As you guys said, if there is an ion, then the charge. And whenever you talk about charge, in the charge part, you just talk about the magnitude, okay? Just the magnitude. Sign is not considered. Right. If you talk about a metal, then we have its valency. The valency is equal to valence electrons per metal. If we have a redox part, a redox reaction, so then it is the number of electrons exchanged per mole. Now here per mole is quite important. Per mole. Right, so these are the ways, different ways by which I can do that, right? Now, apart from these terms, which are written here, there are other concentration terms as well. For example, ppm, parts per million. So that is parts of one component divided by total parts into 10 to the power 6, Abhinraj. 10 to the power 6. That is for 1 million. There is PPB, that is parts per billion. Okay. So in the parts per billion, what will be the power of 10? 9. Right. So if you talk about mass percentage, then what will be the power of 10? 2. So it's all the same thing. Mass of one type divided by total mass into 100. It's a power of 10. Right. So these are the different concentration terms that we are having. Now in this chapter, the major concentration term that you'll be dealing with is molarity, as you're aware. Particularly if you talk about your osmotic pressure, pi is equals to CRT. So वहाँ जो concentration that you use is molarity. And the second one is molality, which you are using in elevation and boiling point, depression and freezing point, right? And the third one is mole fraction, which you will be using in relative lowering of vapor pressure, right? Yes? All right. Now, then after this, there's another thing which suddenly pops up, and that is about the solubility. So when you add whenever you add two components, right? And we are saying it is leading to a homogeneous mixture. It means the two things are miscible, right? So in this particular chapter, we are talking about a combination of those two components which are miscible, right? Which are miscible. Whenever we are talking about two miscible components, which is giving me a homogeneous solution. Right. Now in this particular part, majorly, we are dealing with two things. Now, the two components, out of the two components, there could be a possibility that both are volatile. Right. And there is a second possibility that one of them is volatile. Right. Now, what do you mean by volatile? Easily evaporable, something with a low boiling point. Right. Now, if both of the things are volatile, right, then we have two further segregations, which we are dealing in this particular chapter. That is gas in a liquid and liquid in a liquid solution. Because of course, you know that solid in a liquid, so or solid in a gas will not be volatile. Yeah, not easily, until unless it's a sublimable substance. Right. So these are the two categories: gas in a liquid, liquid in a liquid. Agreed? Now, here, since you're talking about this particular part, a gas in a liquid part is the one for which you're given the Henry's law. Agreed? For this part, you're given the Henry's law, which states that the solubility of the gas is directly proportional to the partial pressure of the gas. So the partial pressure of the gas is directly, and so that solubility, how do you explain? So if the gas is more soluble, if this is your liquid, right? This is the liquid component. And to this component, I'll add some gas particles, right? Some gas particles which were present above. Now, if I give them pressure, then the gas particles will be forced to go inside the liquid. For example, which is happening in the carbonated drinks, right? The thing which is happening in carbonated drinks. So on applying pressure, the gas particles will go more into the solution, right? So what do we say? We say the partial pressure of the gas. Now, if they'll go more inside the solution, so the more they go, that means more is the solubility. More particles present in the solution means more solubility. So if you talk about that particles, so how will I explain that how many particles are actually present in it? How many particles are actually present in it? For that, what would I do? I will devote it with mole fraction. Yeah. I will devote it with mole fraction. That means moles of my gas with respect to the total moles. Because it is the gas which is the solvent. So partial pressure of the gas is directly proportional to the mole fraction of the gas present in the solution. Right? And when you remove the proportionality sign, you will get a constant of proportionality, which is known as the Henry's constant. And this is the mathematical expression of Henry's law. Do you agree? Up till here. Now, please ask me if there's any doubt. And in that case, you just have to raise your hand and then you can speak your doubt. You just have to raise your hand. The people having doubt, please raise your hand. Aditya, Ariba, then I'll tell the names. Chetna, Dipanshu, Diya, Faz, Fawaz, Gautam, Himank, Harini, okay, Hari Prasad, Josefa, I like your name, Josefa, Irene, Kashvi, Krunal, Latika, Mehak Mirza, Neha, Ogle, Ribhav, Rakshika, Rohan, Roshan, Sajala, Sanskriti, Shreya, Siddharth, Varun, Vignesh, Yashwant, Zeel. Guys, come on. I need your participation. Okay? Why so pars are important? Pars are important as in Harini? Like, okay, Harini, can you unmute yourself and speak your doubt, bache?
Ma'am, am I audible?
Yes, bacha.
At the initial stage, you have told that, sorry, not powers, decimal points.
Like 1 and 1.00, that one?
Yes, ma'am,
Okay, bacha. So for that, I told with respect to the JEE advanced paper that sometimes you have to see the instructions very carefully in the JEE advanced, because if there is an integer type of question, in that case, they want the answers as the nearest integer. So that could be 1, 1.91 will be written as 2, 3.84 will be written as 4, that way. Okay, Harmony. But there are numerical based questions in JEE Advanced too. For that, if you look at the instructions carefully, the instruction says that you have to give the answer of those questions up to 2 decimal places or up to 4 decimal places. In those kind of questions, whatever is your answer, that has to be very precise, 5.85, 2.93. So that is just a part of JEE Advanced. Okay, Harini?
Yes, ma'am. Thank you.
Oh, you're welcome. Great. Anyone else with a doubt? Any doubt? No? Everything clear? All right, then. Then let's move to. Oh, yeah. Aaron, you have a doubt.
Ma'am, I'm not sure if many questions will be asked about this, but in module there is conditions of Henry's law.
Yeah.
The first two, pressure should not be very high,
Uh-huh.
temperature should not be too low.
Hmm.
What are the reasons for it?
Okay, that's a good question. So there's a third condition too, which says the two things should not chemically react.
Oh, yes, ma'am.
Yes. Hanji. So Aaron said the pressure should not be very high.
Yes, ma'am.
Yeah. And the temperature should not be very low. See, whenever you talk about the solubility of a gas, right? Solubility means the two things must dissolve with each other. Now, dissolution means whenever I talk about the term solubility, it means the maximum amount of solute which can be dissolved in a solution. Okay, maximum amount of solute which can be dissolved in the solvent, in the given amount of solvent at a particular temperature. Now, when you apply the pressure as very high, in that case, what will happen? There will be a formation of supersaturated solution. A supersaturated solution. That's first. Second, it can further lead to, if you are increasing the pressure, so you are, what are you doing? You are compressing the two things, right? So this can even lead to a change in the physical state of the solute or the solvent, right? If the pressure is too high. Same is the logic for if the temperature is too low. It can further lead to change in the state. Got it? All right. Anyone else with a doubt? No? All right then. Then let's move to the next part, which is a liquid in a liquid thing. Now, for those two components of a solution where both the components are made up of liquids and these two liquids are both volatile, in those cases, we apply Raoult's law. Now, this part is given to you to make sure, bache, that by looking at the language of the question, you should be able to identify that the question is from which subtopic of solutions, right? You just should be able to identify the topic of the solutions chapter by just looking at the language of the question. Now it's a liquid and liquid thing. So Raoult's law. Now Raoult's law has one equation, which is the total pressure is equals to the partial pressure of liquid A plus the partial pressure of liquid B. And this partial pressure is given as P naught A into XA plus P naught B into XB or Xi B. Right? Now, if you try to put it with respect to the same thing, for example, since I can write XA as 1 minus XB, so in that case, yeah, I'll get this equation. which I can definitely compare with y is equals to mx plus c. Right? Where if you see the graphs, this is the x-axis. So on x-axis, I'll put the mole fraction. On y-axis, I'll put the total pressure. Intercepts can give me either P naught A or P naught B, depending key what am I putting on the x-axis. And this is the part of slope. Clear? But this Raoult's law is only applicable for ideal solutions, right? This Raoult's law, which is giving you a straight line equation, is only applicable for ideal solutions. We know in the world, we do not get very ideal things. We don't get ideal solutions much. Yes, still in your NCERT, you will find some of the examples of ideal solutions, right? Yeah. For example, bromobenzene, chlorobenzene, benzene, and toluene. Yeah. Those kind of examples which are given, which are having similar structures. Just like Sharma ji ka beta does not exist, the same way ideal solutions. There is no perfect person in the world. And there is a little deviation. थोड़ा थोड़ा तो deviation सबके अंदर ही होता है ना. Right here. Yeah, true. But like when we'll be in our batch, then we'll discuss the ideal students of our batch. Okay. So when you talk about the ideal solutions, delta H is 0, delta V mixing is 0, and they are the ones which are following the Raoult's law properly. Right. Now, these are the solutions, or these are shown by those kind of components which are having similar structures, molecular mass, and bond polarities. This is the requirement for any two components to work as an ideal component. Right, this is the requirement. Now the question is, what exactly does ideality mean? What exactly does ideality mean? So anyone with an answer? Related to similar, right? So by applying, so basically it means that whatever we are expecting as the total pressure, I am getting similar answers. I was expecting the total pressure, let's say as 2 atmosphere, and I'm getting 1.98 or 1.9. Right. So that means, yeah. And that is possible when the forces of attraction between solute particles is similar to that of solvent particles is similar to that of solute particles. Yeah. In that case, I can expect the same. Where P is P into V. What do you mean by that, Abhinraj? The partial pressure? No. How can you apply PV is equals to nRT here, Abhin? Because that is a gas law, and we're talking about the liquids here. isn't it?
Yes, ma'am. I was just telling about some rules of ideal situation.
All right, true. True. But अब जैसे कि Abin said, there is no exact शर्मा जी का बेटा in this world, है ना? Actually इस दुनिया में तो अक्षता and देवाशीष exist करता है ना? So that is a non-ideal solution, isn't it? And when I say a non-ideal solution, so that means that the expected pressure is not the same than the actual one. अब अगर actual one के बराबर के similar नहीं है तो क्या होगा? या तो ज्यादा होगा या तो फिर कम होगा. Those are the only two possibilities. If my expected pressure is not matching, right, then either the total pressure is more than expected or the total pressure is less than expected. In these cases, right, Bhumi. So positive deviation is like कि मैंने जितना मांगा था उससे ज्यादा ही मिल गया मुझे. So it's more than what you expected. Ideal से भी ऊपर. And total pressure less than means it's like a real thing. So if you talk about the first thing, the first thing gives you positive deviation. And the second part gives you negative deviation. Right? So here we are aware about the conditions of positive deviations. Like here, the delta H mixing is greater than 0. That means endothermic process. Delta V mixing is greater than 0. So total volume will increase. Total volume, why will it increase? Because the two things are not that strongly miscible. They do not want to interlock with each other very well. So that means the forces of attraction between solute-solute and solvent-solvent is way greater than the forces between solute and solvent. So generally A and B is for solute and solvent, F is for force. Right. And in these cases, because we know that pressure is inversely proportional to boiling point, so boiling point will decrease. Right. And I can expect the opposite in case of negative deviation. Yeah. Isn't it? Everything is opposite. Ab. This was a good thing which was working, but suddenly we come up with a new thing. What was the new thing? Now these non-ideal solutions will not just stop here. They're like कि ideal तो हम है ही नहीं, but will give you a good blow in your life. How? Now, whenever there are two different liquids, yeah, we feel that, okay, I can easily separate the two. If there are two different liquids, I can easily separate the two. How? How will I separate the two miscible liquids? How will I separate two miscible liquids? Distillation, true. It could be simple, fractional, anything. Steam distillation, simple distillation, fractional distillation, any sort of distillation, but I can apply distillation, right, to separate the two liquids. So the separation is done by distillation. Is there any possibility by which the separation is not done by distillation? Is there any possibility by virtue of which you cannot do the distillation? All right, true. When the temperature is almost same now, I can still apply fractional for that. Or I can use steam. Boiling point is almost the same. Boiling point difference is less now. But yes, azeotropic composition is right. This cannot be applied on azeotropes. Why? Why? Sharp boiling. Exactly. Yes, Varun? Sure, Varun. So, Varun, we were discussing that, okay, we first discussed the non-ideal solutions, the two cases, and we discussed that these are the points for positive deviations and the opposite points will be for negative deviation. Right, Varun? Then we discussed that if you have two miscible liquids, then you can easily separate them using distillation. But there's a twist in the tail, which is azeotropic mixtures, also known as constant boiling mixtures. Constant boiling mixtures. Now, these are mixtures which cannot be separated by distillation because here the two liquids will start boiling at the same temperature. They behave as a single entity now. They behave as a single liquid now. In the negative deviation, what will be the third point? The forces of attraction between solute and solvent, Harini, is greater than the forces of attraction between solute-solute or solvent-solvent. Okay, Harini?
Okay, ma'am.
All right. Done, Varun? So now when I talk about the constant boiling mixtures, now this is shown by the non-ideal solutions and is of two types. That is, we have maximum boiling azeotropes and minimum boiling azeotrope. Correct. Now, in the non-ideal solutions, which was the case in which the boiling point will increase? In which case the boiling point increases? Positive deviation or negative deviation? Negative deviation will increase the boiling point. So the maximum boiling azeotrope is the one, here it says maximum boiling. So that means more boiling point. It is shown by those solutions which are having negative deviation. Right? And the opposite is the case of minimum boiling. Make sense? Yeah. Now, it happens in such a way that if you talk about the maximum boiling azeotrope, so the boiling point is more than the boiling point of the individual species. In the maximum boiling azeotrope, the boiling point of the solution is greater than the boiling point of solute or solvent. Solute or solvent. All right. Whereas the minimum boiling azeotrope would mean Here, the boiling point of solution is less than the individual boiling points. This is the only important thing here. And on the basis of just this line, you are able to solve or understand a lot of questions based on the graphs. A lot of questions based on graphs. Okay, like, for example, I have a graph like this. Okay, I have a graph like this. Where this is representing the vapor pressure. Can CBSE also ask question based on graphs? CBSE can ask, Amandeep, but CBSE will be asking you questions based on Raoult's law graph. That's it. Not on the basis of azeotropic part. Okay, Raoult's law ki graph karo se. Or boiling point and freezing point ki graphs, because they both are given. All these three graphs are given in this chapter, NCERT wise. Okay. Now, if I talk about boiling point versus mole fraction, right? So here I'm saying that mole fraction of A is 1, and here I'm saying mole fraction of B is 1. Okay. So by looking at this graph, okay, by looking at this graph, can you tell me what sort of graph is this? Like minimum boiling azeotrope, maximum boiling azeotrope? What is here? That's right, Akshat. Minimum boiling azeotrope. Very good. Where point A refers? Boiling point. नहीं बच्चे, temperature तो यहाँ पे कहीं पे भी नहीं है ना. So this part will represent P naught A. Yes. Point C will refer. This part will refer to the solution, the vapor pressure of solution, which is lesser than the individual ones. Yep. Now, do you know that vapor pressure is inversely proportional to boiling point? So if the vapor pressure of the solution is decreasing, the boiling point of the solution will. Understood? And see, this is the mistake you guys did. You guys told the answer with respect to temperature, where neither on the x-axis nor on the y-axis temperature was there. Will the vapor pressure be average of P and PB? Not at all. Not at all. Okay, this is something which has to be calculated. And this calculation is done on the basis of two things. You remember there was this Raoult's law and this Korvalov's law. ये जो दूसरा वाला law है ना, this is the one which is taken up by R. Pyara Dalton. Yes, Arshia. I'll send that. This is nothing but this. Look at this guy. What did he do? He just used the Dalton's equation, didn't he? He was like that, okay, partial pressure of my component A, okay, which is a gas, right? Up the partial pressure of the gas is present here, right? Now, as per Raoult's law, since it is a volatile liquid, so the partial pressure was proportional to the mole fraction of that liquid in the solution. So here, XA was representing the mole fraction in solution state, right? Whereas Y is representing the mole fraction in gaseous state. Now, gaseous state में जो mole fraction होता है, right? So if I would like to give the partial pressure of that gas with respect to the mole fraction of it in the gaseous state, so that is nothing else but Dalton's law, which is partial pressure is equal to mole fraction into total pressure. So this guy didn't do anything different. He just manipulated the Dalton law and proved it, that it is also valid here. That's it. Now this is refurbishing the existing equation. Right. So these are the two cases. Right. Now, when we talk about the next type of case, yeah, right. That's how science works now, on proving. Okay. Now the next case is, okay, we did the gas in a liquid and liquid in a liquid. Now let's move to if one of them is volatile, right? So one of them is volatile, let's say a liquid or a gas that's volatile, and in which a non-volatile solute is present. Non-volatile solute, just a second here, just 1 second, because I started with it. Just give me a second. Okay. So non-volatile solute. Now, if I talk about the non-volatile solute, again, there are two categories. Basically, like if you talk about this part, so category one is if I have a solvent as liquid, and the second category is the solvent is gas. Now, इसके अंदर भी further a category आती है, because in this chapter we are talking about the liquid solvent. If you'll see most of the questions or anything, the liquid solvent is considered, right? So again, there are two categories with a non-volatile solute, that is liquid in a liquid solute in a liquid solvent, which is non-volatile, or a solid present in a liquid. Okay. In these cases, what you are going to use are qualitative properties, where we have 4 such qualitative properties. As you know, we have 4 such qualitative properties, and these qualitative properties are relative lowering of vapor pressure, given as P naught A minus PA by P naught A. Elevation and boiling point delta TB is equal to KB into M. Right. Okay, Harini. Elevation and freezing point delta TF is equal to KB into M. Osmotic pressure, which is pi, is equal to CRT. But as I said, in J, you can have any sort of question. It could be a normal question, or it could be a want-of related question. So want-of factor I has to be multiplied in all the cases. That's the most important thing. Now, any which ways, whenever you are trying, Yeah, depression. Right. Any which ways, जितने भी आपको ये मिल रहे हैं, आप सबके साथ you just have to multiply I, right? Where any which ways the value of I will be 1. The value of I will be 1 in case of a non-electrolyte, right? And I is greater than 1 in case of dissociation. The number of particles divided by initial number of particles. Or normal molecular mass by observed molecular mass. Right. Or you can give it with respect to qualitative property. Observed qualitative property by calculated. Right. And I is less than 1 in case of association. Agreed? Yeah. Clear up till here? If yes, then let's move to the doubt by Nihir. Yeah, Nihir, bacha, you have a doubt?
I wrote it in the chat.
Yeah. Well, does hydrogen bonding by itself, and so it is good. When you add acetone, it does not allow ethanol to do. Okay, so Nihir's doubt is that ethanol and acetone are examples of positive deviation. Okay, and ethanol does hydrogen bonding. This is the explanation with itself. So AA is good. But when you add acetone, it does not allow ethanol to do good hydrogen bonding. Okay, now I'll discuss this. So your doubt is majorly Nihir?
Ma'am, like if acetone is doing hydrogen bonding, then the force of attraction between A and D will be stronger than or could be equal to, like it should not be taken as a positive deviation from Raoult's law, right? Because hydrogen bonding is possible. The explanation they gave is that acetone is not allowing hydrogen bonding in NCRT. So I found it ambiguous.
It is ambiguous. Okay. So, so actually they wanted to say that in acetone, the hydrogen bonding is not present. That's it. Now, if you look at the fact here, there is hydrogen bonding which is possible, and the other case, the hydrogen bonding is not possible. So the particles, like here, the non-polar character is more, since there are more carbon-carbon bonds. So covalent bonding is more in this case. Right. Also, you see oxygen is already electronegative, and carbon, because of sp2 hybridization, is also becoming comparatively more electronegative as compared to the normal regular carbon. And thus the electronegativity difference between the carbon and oxygen bond is less. Right. So if you look at the, and this is the only place for polarity, yeah. This is the only place for polarity. And polarity is Q into D. It is dependent on the charge. Now the charge separation is already less. So is the polarity. So is the dipole moment. Right. So it is because of that, the two liquids are not properly miscible, or they are not having good effective bonding together. Ethanol particles can effectively undergo hydrogen bonding, whereas acetone particles can't. And if I talk about ethanol and acetone particles, right? So there will be steric bulk. क्योंकि इतना कोई स्ट्रॉन्ग रीजन नहीं है ना उनके पास आने के लिए, या तो इतनी स्ट्रॉन्ग हाइड्रोजन बॉन्डिंग वो कर पा रहे, तब भी it would have made sense because the hydrogen has to lie in between two electronegative species for which you take form. अब ये ऑक्सीजन उतना ज्यादा इलेक्ट्रोनेगेटिव है ही नहीं, क्यों? क्योंकि there is a partial double bond character. Okay. So as a result, it was not highly willing. And you know, electromeric effect, probably, I'm not very sure. तुम में से कुछ ना कोई ना कोई बच्चा तो ऐसा भी definitely होगा who will say कि no ma'am, why not electromeric effect? आप electromeric effect लगाओगे तो ये प्लस हो जाएगा, ये नेगेटिव हो जाएगा. There might be people who might be thinking that way. If you're thinking it that way, then I would say you're wrong. Why? Because electromeric effect is a temporary effect which is exclusively observed in the presence of a reagent. There is no such reagent which is going to emphasize it or force it to get like for the pi bond to break into the respective charges. Yes. ऐसा कुछ नहीं है. Ethanol is more like a solvent, so it's not that way. Acetone is equally a good solvent, so it will depend on the amounts.
This example they give for minimum boiling is 0. Maximum.
Acetone and CHCl3.
Yes, ma'am.
They are saying hydrogen bonding.
Yeah, in NCERT it's clearly written.
हाँ, वो उसकी वजह से बोला होगा. 3 क्लोरीन्स है ना, माइनस आई इफेक्ट बहुत ज्यादा बढ़ गया. So
Okay, the same way.
what?
I thought the same way.
अच्छा,
I just wanted to confirm whether
that's the only thing. Okay.
and this is the last one.
Okay.
All 3 NCERT examples.
हाँ, ethanol and water can also do hydrogen bonding among themselves, but still they show positive derivation. बिल्कुल सही है. बच्चे तुम्हें याद होगा that water and alcohol do not mix very well. Okay. The reason being that if you talk about the water particles, it is majorly due to the steric hindrance. A water particle will prefer another water particle to form the hydrogen bonding. The point is not just the presence of hydrogen. See, one hydrogen is already connected to an electronegative element, and the other part is free, right? So if this hydrogen is getting attached to this electronegative element, right? So this is not the very nature of hydrogen to form more than one bonds. It's not the very nature of hydrogen. You remember 3 center 2 electron systems were also found in case of hydrogens with group 3 elements. So you see that if the hydrogen is willing to form a second bond, right? So this is just a mere force of attraction. Now, force of attraction means there is one particle on this side and the other particle on this side, which is coming closer, right? Now, when this is coming closer, you see it is sp3 hybridization, which means it's a 3D molecule, right? There's a carbon, there's oxygen, aldroid. Okay. So basically, if you look at this part, these all are like balls. Everything is like ball. There's this ball, this ball, this ball, this ball. Now this hydrogen, you are saying ki, aao babu, you have to get attached to this oxygen. Right. So basically there are repulsions. Okay. You might say, ma'am, then what about two ethanol molecules? Even they are facing repulsion. In fact, their repulsions are even stronger. Right. Of course, you can say that. And I'll agree to that. But there is a condition. Remember, like dissolves like concept. Yeah. Now, if you look at this part, this is having a hydrophobic character and a hydrophilic character, which is not the case. Water and ethanol mixture is isotropes. No, it's not that water and ethanol mixture is an isotropic mixture. For two components to form an isotropic mixture, there is a specific composition required. For example, ethanol के case में it is 95% ethanol, 5% water. So if you will take it in any other different condition, okay, which is also known as absolute alcohol, अगर आप कोई भी different conditions लेते हो, in that case it won't be an isotropic mixture. So now if you have this hydrophilic part and this is hydrophobic part. Now if I talk about another molecule of ethanol, even that has a hydrophobic part and even that has a hydrophilic part. So when I talk about like dissolves like concept, hydrophobic parts will be attracting each other. Hydrophilic parts will be attracting each other. This was the same thing which you've done in 10th grade. जब आप लोगों ने first time you did that micelle formations and the cleansing action. So long chain of the detergent and the shorter last chain of the detergent. This is based on the same concept. Okay, and water particles, they actually show one water particle will show 4 hydrogen bondings. But because of the steric hindrance of ethanol, it will be able to just form a single hydrogen bond. This is also a major factor, you see. Water forms 4 hydrogen bonding with other water molecules. This can only form 1 hydrogen bond. You see, more bonds, more is the force of attraction, more is the stability. Simple funda. Yeah. So the interactions between water-water molecules are more favored in nature as compared to water and ethanol because of the number of hydrogen. Got it? Oh, you're welcome. Anyone else with a doubt? Anyone else? No? Okay then, so before ending things, I would like to discuss just one major part. Okay. Like, yes, I'll be sharing how to get the notes. So the notes I will be sharing on your WhatsApp group. So I'll send it to your respective teachers. Okay. And they will be sharing it with you. All right. Okay. So guys, when you'll be shared with these notes, then these are the questions you are expected to do. And in the next class, we will be discussing the solutions of these questions. Yeah. Yeah, Nihir, I can see that. So I'll do that and I'll either take the snapshots or I'll see if the PDF can be converted. Because it is saved for me at least. Yeah, saved offline. Saved for me. So I'll convert it into a PDF and then share it. Okay. Hanji. So there are these questions. Once the notes will be shared, you just have to do the questions. And in the next discussion of the revision part, we'll be having the doubt clearance of these. Bache, the entire notes will be shared to you, Rahul, via your WhatsApp group. So I'll be sending it to your respective teachers. Okay. So I think for some of you, Kajal ma'am is taking your 12th. For someone else, Ashutosh sir is taking. Yeah. For some other people, it's Anik sir also taking. For anyone? Yeah, I know. Abhin, so don't worry about that. I'll do the thing. Either I'll paste it and make the entire notes, or I'll copy the notes in this inside else. So don't worry. Hanji. So I'll be sharing it with your respective teachers so you can further send it in your, like, check in your group. Okay. So that's all for today's session. And we'll meet in our next class, the next session, next week, and we'll be discussing further. I think the topic would be solid states. Okay. Take care and good night. Enjoy your time.
Thank you.